All right, today we're moving on to solving radical equations. Radical equations, those are equations where they contain expressions with a variable under a radical symbol. Now, you've seen a radical symbol, you've just probably never heard it called that. A radical symbol is just a symbol like this. So why don't we just say the square root symbol? Well, because sometimes it's a third root symbol, sometimes it's a fourth root symbol. We could have a 70th root symbol. Whatever this number is, just means that we're taking whatever that root is. If both sides of an equation are raised to the same positive integer power, then every solution of the original equation is the solution of the new equation. In other words, in order to get rid of this square root, if I square both sides, I'm allowed to do that. It's not illegal. It doesn't make it mathematically correct. It's the same thing as like whenever I had x plus 5 equals 6. When I subtracted 5 from both sides, as long as I do it to both sides, it's allowed to happen. It's the same thing with radical equations. As long as I do it to both sides, I can make it happen. So whenever it comes to solving these, though, the best way to do it, best course of action here, is to first get the radical by itself, which means that I have to subtract 5 from both sides first. That leaves me with square root of 3x minus 11 equals x minus 5. Now, in order to solve this, I raise both sides to the second power, because that will cancel this radical out. On the left side, that just leaves me with 3x minus 11. On the right side now, I have to square x minus 5. That's the same as x minus 5 times x minus 5. So I can either FOIL this or just know your rules. It's the first term squared. And for the second one, it would be negative 5 times x times 2, which would give me negative 10x. And then negative 5 squared is plus 25. Now just get it all on the same side. So I'm going to subtract the 3x over and add the 11 over. Then I'm going to add this 11 over. That's going to leave me with 0 on this side. Then x squared minus 13x plus 36. Now I can try to factor this. Think of things that multiply to give you 36. That would be like 12 times 3. That's not going to add to give me negative 13. I can do 6 times 6. That's not going to add to give me negative 13. So since I can't think of any right off the top of my head, I'm just going to go with, I thought on one for a second, 18 times 2. That's not going to give me negative 13 either. So now I'm just going to go with the quadratic formula. Negative b plus or minus the square root of b squared minus 4ac all over 2a. Now let's solve this. Gives me positive 13 plus or minus the square root b squared. That's negative 13 squared, which is 169, minus 4 times 1 times 36. All over 2 times 1, so just 2. Now 4 times 36 gives me 144. So I'm doing 13 plus or minus the square root 169 minus 144 gives me 25. Square root of 25 is 5. So it's 13 plus and minus 5 over 2. Thirteen plus 5 is 18 over 2. This one's going to make me look stupid, which is 9. 13 minus 5 over 2. That's 8 divided by 2, which is 4. Those are my two roots. Now remember back here when I said I couldn't think of anything that factored to give me 36? Well, clearly I didn't think about 9 and 4. Because if I would have, well, then I would have got my right answer. 9 times 4 is 36. Negative 9 minus 4 is negative 13. Well, what are you going to say? I can't be perfect. I know you guys expect that of me. I know I usually am perfect, but not all the time. And that's our word of the day. Perfect. For 5 bonus points, please send me the word perfect in an email, and we'll get that added on to your next chapter test. All right, example 5, using the power principle twice. So the thing with this example is it's our last example. But the thing with this example is I have 2 separate roots. So if they're both on the same side with a minus in between them, or adding them together, there's nothing I can do here. If I square them, it's not going to give me anything pretty. It's going to get rather ugly. So the best way to handle this is to get one of these over to the other side. I'm going to go ahead and add this over to the other side. So now that gives me the square root of 2x minus 3 equals 2 plus the square root of x plus 7. Now I can square both sides. Now when I do that, it's still going to make this side ugly, but it's going to fix this side for me. So by squaring that, that cancels my radical out. I'm left with 2x minus 3. On the right-hand side, it's going to give me 4 plus 4 times the square root of x plus 7. And then it's x plus 7, square root of x plus 7 squared, which that'll cancel my square root out. So I have 2x minus 3 equals, and I'm just going to do 4 times the square root of x plus 7. By canceling this square root out, I'm just left with x plus 7, so I can combine that with my 4. So plus x plus 11, because 7 plus 4 is 11. Okay, what do I do at this point now? Because I still have this square root. Now I'm going to get all of this to the other side and square it again. So subtract my x, subtract my 11 from both sides. That gives me x minus 14 equals 4 times the square root of x plus 7. I said 7, wrote 6. It's weird. Now, right now, I can divide by my 4, or I could just wait. I'll do it now. Gives me x minus 14 over 4. Now I square both sides again. It's going to give me just x plus 7 on this side. Over here now, I'm going to do x minus 14 squared. So that gives me x squared minus 28x plus 196. I did negative 14 times x times 2. 14 squared is 196. Over, I have to square the denominator as well, 16. Now let's get it all on the same side. Well, I could keep going with this way. I'm thinking about the fact that this 16 is over here. I really should have left it over, the 4 over here before squaring it. So now I can multiply the 16 back over, which is really like undoing what I just did. Because I don't want to have to come up with a common denominator for both of these and make it work that way. It's a real pain. So I'd much rather just do it this way. Distribute my 16 to both terms. And then 16 times 7. 112. And that's much better. So now I can subtract my 16x away. Subtract the 112 over. Gives me x squared minus 44x plus 84. Now we can either do quadratic formula or see if there's something that multiplies to give us 84 and adds to negative 44. Just thinking off the top of my head, whatever multiplies to give us this would have to be a pretty big number to add to give you negative 44. So I'm going to think about 42 and 2, and those would add to give you 44. So those are my right answers. Set those both equal to 0. So x equals 42 and x equals 2. All right. Sorry about the 16 there. If we went back up to where that part of the problem was, before I divided by 4, I can show you just how to make that difference without actually dividing it and then multiplying it back over. If this is 4, and I square this now, and then I square this side, like I said, definitely should have done this from the start. Squaring this side is going to give me the same thing that I had. On this side, whenever I square this, I square the 4 out in front, so it's 4 squared, which is 16, and then times x plus 7. And now we end up back to down where we were here, where it was x squared minus 28x plus 196 equals, distribute to 16. So this would have been the much better way to do it. Anyhow, you got some bonus points out of it if you watch the video. So